I'm over here on board number 2, and the problem is that the game is not starting. But I noticed an application, there was a very light signal when I put it in the machine and tried to actually physically start it. There was a very light signal on the blower, almost like you could hear it just boop, boop, start, which gave me a clue because I had already replaced a couple chips here. I had replaced 2 chips here with the 7400s using the cheap version, and I didn't get the result I wanted, although I did clear up a few bad gates that were appearing. And I also changed this other control chip that functions with these 2 for the game control, but also runs with the flip-flops for the scoring. And still, the game would not function. Now, this chip here definitely had to go because one of the legs had rusted right off of the chip, and obviously that was not going to function anymore, even if the chip was good inside. So I got a clue when I realized that the blower was just slightly, ever so slightly, you couldn't even hear it, just like a little bloom, starting on the thing, that if you had any noise in here, you wouldn't hear it at all. So then I realized that it's almost like it's starting and then immediately going into a game over mode. And since we don't have a game over light that would tell us that's happening, we have to just kind of use a little deductive reasoning. So then going over to the schematic diagram here, looking, and I said to myself, well, what could turn off the game? Well, there's score. If you hit the score of 7, it'll turn the game off. So it could be the scoring that's turning it off, or it could be a time run out that is not functioning right on the board that is immediately turning the game off when it starts, like not allowing any time, could be shorted. So I'd say the most logical one would be a scoring situation. And we look at our 2 scoring sections. We have actually 2 separate ones. This is for the one side and this is for the other side. And then if you follow your schematics over to this gate right here on chip number A9 for pin 12 and 13, all right, that's a NAND gate, and we're coming over to the flip-flop from the final score on one side and the flip-flop from the final score on the other side. I tested with my probe the pins of this gate here, chip number A9, pins numbers 12 and 13, and one of them was low when one of them was high. So definitely they should both be in the same condition at the reset start of a game because they're coming in. If one should change, it'll change the output on that gate, which then goes into this gate, which then goes into the sequence here, which is going over to the other chips and probably turning the game off. I did track it down to the flip-flops over here. Now, interestingly enough, this board was modified. Somebody had put a switch on the back of this board so you can switch from a 5 scoring game for game over to a 7 scoring game, 7 being the normal. So it's too long of a game with 7, so they put a switch on it so you could change to 5. So being that way, I was able to use the switch to sever the signal coming from the flip-flop over to this chip that it was set on to the other one. And when I did that, guess what? When I triggered the game, do you hear that? The game is running. Solenoids came on, blower is on, game is functioning. Okay, so we have a problem on the flip-flop. But it's not just one of those flip-flops, because when I tried the scoring is not functioning correctly. So now we'll go over to the score switches and see how we're working. So this score switch is probably energizing that light bank over here. But we're starting the game and we have one light lit. And that's light number 5. Well, we shouldn't have any lights lit. On the other side, we're clear, we don't have any lights lit. So, we can zoom in and watch those lights over there. I can't zoom my camera, but let's hit the switch once. Look at that. We got the score of 1. That other light, which shouldn't be on, went off, but came back on again. What happens if I flip it again? I'm not going to 2, but the other light keeps blinking on and off. All right, so that means we have a problem over here in that array of flip-flops, and it's probably stemming from the gate that is controlling light number 5. It could be going back to keeping this from flipping, so my best guess is that one there. Now, as we go to the other side, and we flip the switch, we got to watch the other score. Flip 1. All right, wait, we got a light, but it went right to light number 3. It did not start with light number 1 or light number 2. It went right to light number 3. So there's a problem on that set also. One more flip. It disappears, back on. Disappears, back on. Disappears, back on. So we go back to the schematics to see what is controlling our flip-flops. Well, put my other set of glasses on here. I gotta wear 2 sets of glasses for this one. Okay, that means I'm getting old. As we look over our schematics, our flip-flops are being controlled in a parallel, coming over here, parallel 1, parallel 2, okay, and it's coming over to the counting Schmidt triggers. Well, those counting Schmidt triggers are running through chip number A10, chip number A8, again A8, A10 with a cross Schmidt. Capacitors C12, C11 are holding the signal for a little bit of a duration, so we can check to see if our signal is being affected what's going into the Schmidt diagram. Actually, the capacitor is on the outside of the Schmidt. The trigger coming from the puck switch over here, puck switch, those are going in, being brought down to a positive through a resistor, then going into the Schmitts. So after the control, we go over to the capacitors for the line to the flip-flop. So we can test out all of this right here simply by tapping onto our capacitors with our logic probe and finding out if we're getting a proper signal. First of all, to trigger this without having 2 people here and 100 hands, I'm going to connect a negative lead to my screwdriver so I can probe. Yes, folks, there are such things as probes, but when you don't have one handy, you use your handy screwdriver. And these are the capacitors that I changed with those non-proper figures here. Instead of using the acyclic capacitors, I didn't have them, so I used extended legs. Now, these would be the 2 sections here. And what are we getting here? We're getting a high and a high. All right, so we're both high. This is my inputs coming in. This group of 3 would be the coin because we have a normally closed, but we don't have a normally closed over on the puck count. And the first 2 are for the solenoids that are holding the puck. The second 2 would be the puck count, and we got to be going through resistors as we saw onto the schematic. So I'm guessing it's the first 2 resistors here, which would be your puck count, and they are both connected to a positive bus. So on this side here, we should also have positive, and those should be going over to your Schmidt diagram. So if I take my grounded screwdriver, and I'm going to use my logic probe, and to try to do this on the camera so you can see it is going to be really hard to do. So let's see if I can get my probe over here. All right, I'm going to put my probe on the 1, and we're getting a red. Now if I simulate a puck, Look at that. It went green, red. And the reason it goes green and holds is because of that capacitor. So hit it once, green, red. So that's good. Now over here, we should get the same thing on the other resistor. And we do. Green, red, green, red. So by that little test, I have determined that these resistors are perfectly fine. The circuitry as shown in the schematic, as far as the pulsing counting Schmitz, are working perfectly fine, going through these capacitors and then going over to my flip-flops. And that means that one or more of those flip-flops are bad. Well, surprise, surprise. So that means I gotta have some more fun with chip pulling. And I'm going to, I see there's some rusty legs on there to begin with. Those legs are really not in what I would call good condition. Look at the rust over here. We could spend a lot of time probing away at those flip-flops, or I could change the ones that I suspect. And we know from looking at the lights that I suspect that trigger number, 5 on the one side, trigger number 3 is instantly coming on the other side, probably controlled by the first 1 and 2 because they're not working, they're just jumping over to number 3. So the first one is probably bad on the one side, and I'm gonna guess the 5th one is bad on the other one. So time to pull some chips and see if I got some other flip-flops to put them in. Now we're back on the same board, and I have replaced the first chip, and I have replaced number 6. Well, why did I replace 1 and 6? Well, if you remember, on this counting array, this block here, I was starting at 0, but when I did the first goal, I only lit up number 3. And I'm pointing to the second chip because each chip does 2. We have score 1 on this side, 2 on that side. So 3 is over here. So we were jumping to 3, so I suspected this chip here was bad for 1 and 2. On the other side, if you remember, we were starting with lit number 5. So we have score of 7. So we have 1, 2, 3, 4, 5, 6. 7 is on half of this chip. Then 1 is on the other half. 2, 3, 4, 5. 5 would be on this chip. 6 and 7 would be over here. So I replaced this chip that has to do with number 5. And I replaced this chip that has to do with 1 and 2. So we put it back in the board set, and let's see if we still start up. Let's hit the coin switch. Very good. So the game circuits are still working to start the game. And last time I started the game, number 5 was already on. Number 5 is not on anymore. On the other side, we started with nothing, and that's correct. So let's coin here and see what happens over there. Remember, number 5 was lit. Number 1 is coming on without number 5. Perfect. Up. I'm not going beyond number 1. Number 2 is not lighting over there. Okay, well, we're a little bit ahead on this side. On the other side, remember we started by first score going to number 3. Where are we? First score is number 1. Perfect. Second, number 2. Perfect. Number 3. Perfect. Number 4. Uh-oh. Not going beyond number 3. So, I did replace 2 chips, and they were both bad. So now we're going to be back over here changing some more chips. Okay, so this side, we were, number 1 and 2 is working, 3 is working, but we're not going to 4. So I suspect this one here, because that would be 5, and if that's bad, it would hold back 4. On the other side, We're going okay with number 1. 1 is shared on this chip with 7. So this one's probably bad for 2 and 3. So let's change 2 more chips. Here we go. Okay, let's see where we are now on this fun project. We're back on our board, and on this group, we were not passing light number 3, which would be on the first stage here. I went ahead and changed this chip, which does 5 and 6, because 5 would connect to 4, and I suspected that's what it was going to be. Now, on the other side, we were only doing light number 1. We were not going to light 2, 3, 4, 5, 6, or 7. It wasn't going past. But 5 was out because I had replaced that chip. Okay, the number 1 comes on this side here. 1 is on this chip, the right side. Then we have 2, 3, and then 4, 5. Now, we had found that the 5 was bad. We changed that, but we weren't going past 1, so I changed the chip that does 2 and 3. So let's see where we are. Let's get some coin up. Very good. And we'll see how much progress we made. Okay, that side there was not going past score of 1. 5 is no longer lit, which is good. Score 1, we got our light. Score 2, look at that. We have number 2. Number 3, perfect. 4, great. 5, wonderful. Uh-oh. We're not going past 5 now. Well, we're making great progress on this. If you remember, 5 was stuck on, and we were only getting 1, wouldn't go past. Now we're going 1, 2, 3, 4, 5 in order properly, but we're not going to 6 and 7. The other side, we were on 1, 2, and 3, I think it was. Let's see. Score 1. Score 2. Score 3. Nope. No progress on that one. So that chip for 5 and 6 was probably bad anyway, the way this is going, but it didn't cure the problem for the score past 3. So we will be back over here, and we're going to change this chip here, which has 3 and 4. So the 4 is probably bad. Then we'll see if we go into 5 and 6 properly. This has 7 and 1. We know the 1 is working because that's the other side. We know 2, 3 is working. 4, 5 is working, but 6 and 7 is not. So you're next to go. You're next to go. And we might only be left with 1, or they might all be going. So we'll see. Isn't this fun? Such suspense. All right, here we go one more time. And now you see I have replaced this chip here. And which one was it? It was this one. No, this one here. This was changed. The only one left that is not changed is this one, which does 7 on the one count and 1 on the other. And of course, my opto isolators over here and all your peripherals seem to be okay. At least they test that way. So let's see how we go now. We got to plug ourselves back in again. Which plug was it? Was this one? Don't you love the suspense? And let's trigger a coin. Machine starts up. Sounds good. Certainly no smoke. That's a good sign. So let's see where we're at. Coin 1. Should I say puck 1? Perfect. Puck 2. Perfect. Puck 3. On. Puck 4. Good. Puck 5. Perfect. Now this is where we were stuck last time. We couldn't go past 5, will we? Look at that. Puck 6. Now, if I energize puck 7, it should light up and turn the game off. We should hear a click. And let's see. Do we get puck 7? Perfecto. Perfectamundo. Here we have all 7 lights for a score of 7, and the game shut off just right. So that side is perfect. Now we got to start the game again because we got to check the other side. Where is it? Yep, there we go. Did we reset? We reset our lights. Pucks are in. Blowing motor's going. And let's trigger puck number 1. Perfect. Puck number 2. Right on. 3. Perfect. Now, we were stuck past 3. We couldn't go to 4. Will we go to 4? Puck 4. Puck 5. Puck 6. 7 should turn it off. Perfecto. Perfectamundo. Yes, sir. Well, I gotta say, not only is it working, but it's actually working better than the other board, because the other board, I've got one light out because of a PNP transistor and at least 2 resistors, which I checked at home. I did not have a match, so I had to order it. So this board, which is the cleaner board, the newer version, with the relay switching instead of the opto isolators in the triac, which this one has over here and no relay. This board is definitely still cleaner, but this board now is going to be much easier to service, because if anything happens in the future, every chip on here in control line, except for the opto isolator, has been replaced, except for this one, with a new chip and sockets. So you'll notice they're a little higher because I put sockets in every spot, so I can pop one of those chips out really, really fast and pop another one in, assuming I have one at the time, and replace the circuit. Now, the question would be, if you're analytical, why did all those chips go? Well, I guess we'd have to have a crystal ball to really know the proper answer, but my theory is this all started right here with this chip and this chip, which are your start chips. Now, why did it start there? Let me unplug this so I don't make a problem. These 2 chips are controlling the game operation, and they work together with this chip, which allows the signals to go to the matrix array of flip-flops for the scoring. So everything is interconnected. That's why they call it integrated circuits. So when one of these chips failed in a catastrophic manner, it took the other one with it. And then, because these chips connect here to turn the game off, it shorted them out. Now, where did it short them out? Remember, we started with light number 5 on this group here was staying lit. Well, if you remember what I told you, let's pull this out and show you the bottom. The back of this board has been modified. This other board has not been modified. You see that is perfect. This board has been modified. You see all these wires, which do not exist, and this switch. So somewhere along the line, some technician put this switch in to switch from 5 to 7 as far as your puck score to turn the game off. Therefore, they had to make some alterations on the board. Now, let's see how close we can get here. Under here, move this over. You see that wire? Right here, a trace has been cut. Right there, that's a cut. And they've cut it again over here. There's so much rosin from my chip soldering that you can't really see it, but it's there, it's cut. So why did they cut that? Because this was the signal that came down and went to the turn on, turn off circuits. And again, over here, this was the signal that went over to the turn on, turn off circuits. So what they did was they tapped on to the 5 and the 7, and they put a switch. It's a double pole, double throw. So if you are on 5, it connects the 5 wire to the spot where 7 was. And if you're on the 7, it connects the 7 wire back to where it was for the turn off. Same thing over here. The 5 connects to the common where it's cut, or the 7 connects to the common, which is cut. So there's nothing wrong with what they did. But what happened is, when these chips blew in a catastrophic failure, it took out whichever chip was connected on the 5 and the 7. So they blew chip 5. If you remember, the 5 was staying lit. They shorted that out. And then when they switched to the other side, they blew 7 because these chips were still catastrophically failed. And the same thing happened over here. So what happens with flip-flops is each one talks to the other in a communication array. So when one fails over here, it's going to damage the one next to it that's communicating it. And if that's damaged, then it's going to damage the next one over and the next one over and back and forth. And the only survivor is right here. He's the only one who survived the catastrophic failure, which probably happened, I'm going to say 30 or 40 years ago on this board, because that machine hasn't been used in all this time. It's in 1973. This is an original board, so it's been there all that time. It was modified at some point, but at what point, I don't know. The arcade it was in closed definitely in the mid-70s, mid to late 70s. So how long was it broken in the arcade? I don't know, but it's been sitting in that arcade since probably 1976, 77. And here we are at 2023. So this board is 100% perfecto. I don't like the fact that it's not using the relay technology and it is running the blower directly from a triac, because that could be a lot of current being pulled on that triac and blow it. They didn't change it in a redone model with a relay in there. See the relay down in the bottom? It's covered over my paper. See the relay there? Right there? They didn't do that for no reason. So what I might do, I've already spent enough time on this, I might put a relay in, but I won't do it exactly the same way. I'll put a relay down in the bottom here, and instead of sending the power from this harness directly to the blower, I'll send it to the relay and then let the relay do the master switching over to the blower. So it'll ease off some of the power consumption and the demand on that triac. That is the story of the Brunswick air hockey machine. Now, when you guys come in and you come to the arcade and you play the machine, it's always fun to play. But very, very few people actually realize what it took to get that machine there for you so you could enjoy it. So this is a little taste, a little education for people. Those who are technical, I'm sure, enjoyed it more than others. But it's certainly something that people should understand and should know. This machine was made in 1973. The year I'm filming this is 2023. That makes this machine 50 years old. And if there's one thing that's not fun, is working with solder that is corroded from 50 years of being down at the shore. Nothing melts nicely. You have to try to really get down into there. But I did a great job. I didn't ruin any traces. Somebody did this one before. You can see they broke the trace. That's a long ago repair. They broke the trace on that. They had to put the leg over to catch it again. I lost one trace here when I did that. One trace was not working, and that was a ground. So I jumped it to the next chip to bring my ground over to it. So that's the only jumper I had to do. This was put in prior when they replaced that triac. And you can see that they have just done a modification there because the original holes were up here. And they had to make it down here because it was bigger. The bolts are rusted over. So that's not coming out very nicely or pretty if it ever has to come out. And hopefully it won't ever have to come out if I put that relay in there and change it and lessen the load. So here we have it. The Brunswick air hockey. It's fun. And again, I'll say I could have just put in one of my newer models with the stainless steel top and let it go with that. But I had a fun project. I got to share it with you. And now when people come in, they'll get to play an original Brunswick air hockey machine right here at the Retro Arcade and Fascination. See that? Pretty excellent. I found in my supply some mallets. I remember when they started making these mallets, they were lighter weight and you had to hold your fingers in here. So you couldn't get as good a grip in these short ones with the tops like that. They're not real short. Got an extra puck. So we got some old mallets and puck in this box here because I always like goodies. What kind of goodies do we have? Look what we got here. A bunch of brand new mallets. And these are the, the good ones with the big handle to hold on. That's the way they originally were. And a box of pucks. And we know the pucks originally were yellow because there's the original yellow one over there. So we got the yellow pucks. And why do I have so many mallets and so many pucks? Because I know from past experience that people are going to carelessly play and a puck or two is going to go flying off the table and probably land under something else or land in the cool gunman over there or behind the counter. And sometimes it's not so easy to find them. So we just grab another puck and we keep the game going. And then at some point when we get to move stuff around, we find the pucks and we're back in business. So you wouldn't believe how much a puck costs, a piece of plastic or a mallet. But this is what you do when you have fun and you sell fun for people. You got to create the magic. And that's what I do. Been doing it for 44 some odd years. And I enjoy it. And I'm in good shape right now because I not only have one working board, I have two. So if one goes down, I'll swap it out and I'll have time to work on it. And being a 50-year-old board, the chances of it going down, they're up there. From the Retro Arcade and Fascination as we get ready for the beginning of our new season. We're going to be open for Easter weekend, but only Easter weekend because they're still working on the boardwalk with the construction till sometime in May. So I'm going to open for Easter weekend for customer accommodation because I know there are certain people who love to come down and play Fascination. And Fascination will be open from our side door because we have no boardwalk entrance until they finish the boardwalk construction. Then we'll close for a couple more weeks and allow them to finish their construction, and we'll be open in May full-time for the season. And you can come on down and be sure to play the wonderful Brunswick air hockey machine right here at the Retro Arcade. And now you'll really appreciate it when you play the game. Thanks, guys. Enjoyed the episode. I enjoyed making it for you. So we'll see you next time from the Main Street Randyland YouTube channel. Hooray! Bye, guys.